Welcome to Tuesday Lunch and Learn. I'm James Shore. Every week we choose a software engineering problem, come up with a challenge related to that problem, and then solve it live on stream. And this week it's microservice architecture, specifically having microservice architecture without the cost of microservice architecture. I said every week, but today is our last live stream. This is the end of the Tuesday Lunch and Learn series. And the reason for that is that I am working on the second edition of my book, The Art of Agile Development, and I'm going to be taking the time to focus entirely on the book. So I'm not going away, but I am going to stop the stream. If you'd like, the book is in open development, which means that as I work on it and finish chapters, I'm actually going to put them up on my website for people to read for free and to provide feedback on. And if you'd like to see those, go to jamesshore.com/s/AOAD2 to get to the book homepage and get all the information about that. There's an open review mailing list if you want to provide feedback on what you read and get informed about new updates. Or if you just want to get the updates themselves and nothing else, you can go to jamesshore.com/s/updates, and there's various ways to sign up for updates about my announcements. You can also follow me on Twitter or follow the hashtag AOAD2 tag on Twitter, and those are also good ways of getting more information about what's going on. So today is the last episode. I really appreciate everybody who's been following me along up until now, and I do hope that you enjoy today's episode, which is going to be about microservice architecture without microservice overhead. Now, microservice architecture is the most popular architectural approach I see. It's, of course, it's applications composed of small, loosely coupled services. Each service runs in its own process and communicates with the other services via the network, typically over HTTP. Each can be written in its own language and has its own data store, its own database. Now, we have written a little Rote 13 application using a microservice architecture. It's all in a mono repo here. We've got a command line client that talks to a little Rote 13 microservice. And of course, the way the Rote 13 is a little text encoding protocol or text encoding algorithm that you see online to hide spoilers. Now, let me show you how this works. Again, if you'd like to follow along, you can follow the code or get the code from github.com/jamesshore/livestream. Check out the tag 2020-09-29. Once you've done that, you'll need to install node.js because everything's written in node.js, but everything else is vendored in, and you should be able to just run the code in the same way that I do. Now, to run the code, we're going to run the server using serve 5000 /serve.sh on the Mac and on Linux, or just serve on Windows. And that will start the server. And then you can run the code by running /run or run on Windows 5000, and then whatever text you want to transform. And that will go out, make the call to the server, and then give us the transformed text back. So that's what we've got written. And that it's a nice way of organizing your code, but it does have flaws. Specifically, network calls are slow and prone to failure. And let me actually show you that. If I run this server again, now I've arbitrarily programmed this to have a delay after half the calls. So you can see right now the server is just hanging for 30 seconds. So we've programmed the code to time out after 5 seconds. And that's the kind of stuff you have to do with a microservice architecture. Network communications are not guaranteed. They will fail. So you have to program your code to handle those failures. You have to handle the server not working the way you thought it would, having arbitrary problems, or timing or hanging, as we've seen here. In addition to that, managing a large number of services tends to be costly. There's a lot of operational overhead to having hundreds of servers that are all sort of interacting with each other. And simple problems like coherent transactions, which are easy when you have a single server, turn into distributed transactions when you have a microservice architecture, and that's much more complicated. So you have to write a lot of code to manage all these problems. And Fred Brooks wrote an article back in the 80s called No Silver Bullet, Essence and Accident in Software Engineering. And you may know of him as the author of the book, The Mythical Man Month. Fred Brooks defined design problems as falling into two categories. You either have essential complexity or accidental complexity. And essential complexity is the complexity that's inherent to the problem that you're solving. So if you look at all the files, all the code that's involved with our little command line application here, only 3 of them are really essential complexity. We've got to have the command line application, we've got to have the command line infrastructure, and we have to have the road 13 transformation code. Everything else is accidental complexity. It's a artifact of the way we've chosen to solve the problem, not something that's inherent to the problem itself. And specifically for us, we've chosen to solve the problem with microservices, which means that we've got all this complexity around HTTP communication. We've got the HTTP client calls, we've got the server, we've got the error handling, we've got the logging, we've got the timeouts, lots and lots of stuff that's not inherent to our road 13 application. So why incur all this overhead? Well, the biggest reason people use microservice architecture is that it allows them to prevent the big ball of mud problem. When you've got a really large application, it's very tempting for people to go poke in to the private details of other parts of the application, and then you end up, and as over time, as more and more people do this, you end up with your application being all interrelated like spaghetti, it's spaghetti code. So when you use microservices, because they're physically running in different processes, typically in different code bases, it isn't possible to have a direct call from one to the other. So you prevent that big ball of mud problem. It's sort of a sledgehammer to solve the problem, but it solves a real problem. That also gives you a clear separation between teams. Now that you know for a fact that these code bases are isolated from each other, it's really easy to say, well, this team's going to work on this set of microservices, this team is going to work on this set of microservices. It also allows you to upgrade your technology in isolation. In some languages, it's very difficult to have 2 versions of a library running at the same time. So by having your code running in multiple processes, you can upgrade the library over here without upgrading the library over here and breaking the stuff that depends on that library. Now, there are a couple of other things that people say are benefits of microservices, but in my experience, aren't as such of a benefit. And one of them is independent deployment. It is true that with microservices, you can now deploy each service independently of the others, but you have so many services, your operational burden is actually much higher than microservices or much higher with microservices than it would be if you just solved your deployment problems. Similarly, microservices can be independently scaled. You can take this service and scale it out and not scale out these services, but that's more a function of network routing. If you have a monolith with multiple endpoints, you can copy it out to multiple servers and just choose to route certain endpoints to certain servers, and you get the same basic scalability benefit. So those benefits that people talk about are sort of questionable in reality, but there are real benefits around preventing the big ball of mud problem, providing clear separation between teams, and allowing you to isolate your technology in isolation. So our challenge today is to take our road 13 application, remove all this accidental complexity while still giving us these benefits. We want to cut the number of lines of code in half. We want to cut the number of tests in half while also simultaneously improving our test performance and improving our run performance, and doing all of this while keeping our design quality, our ability to have separate teams, and our ability to selectively isolate. So the question is, how do we do that? Well, while you're thinking about that, I want to remind you that this show is made possible by the people who hire me for training and consulting. Now, this is the last episode of the show, but the folks that hire me also make it possible for me to work on the book, the 2nd edition of The Art of Agile Development, and to do so in a way where I can put that all online for you to read for free. Lars, thanks for the comment. So if the people who hire me tend to have the capability for a lot of business agility in their organization, but they're constrained in their technical capacity in some way. Maybe they have more bugs than they want. Maybe they have long release cycles. Maybe they just don't have the performance or the capacity from their teams that they're looking for. Maybe they would just want to see more results. Folks who want that, hire me to help with training on technical issues, also process design, particularly for teams, for companies as they grow and they add more teams, they start to see bottlenecks between teams. Certain teams become the point of failure for other teams. And solving that is a matter of process design, but it's also a matter of social issues. How do you have people work together? And it's a technical issue too. How do you organize your responsibilities with things like microservice architecture so that people can coordinate effectively? If this sounds interesting to you, go ahead and send me an email, jshore@jamesshore.com, or visit me online, jamesshore.com. Also welcome tweets from anybody at any time. Visit me on Twitter @jamesshore. Okay, let's get back to our challenge. We want to remove the accidental complexity from our system while retaining the major benefits of microservices. How are we going to do that? Well, let's look at what we have right now. We say we want to cut the number of lines of code in half. Let's see how many lines of code we actually have. Now, if you'd like to follow along, again, github.com/jamesshore/livestream. The tag is 2020-09-29. You can, once you've done that, you can run the build by typing build.sh or just build on Windows, and that will lint all the code and it will run all the tests. So let's let that go. So you can see we have 172 tests, and it is taking, let's see how long that's taking. It's not giving us a really fine-grained answer there. Let's just run the tests alone. So it looks like it's taking us about a second to run all those tests. Let's call it 1.67 seconds. And if we count all the lines of the code, we've got 3,980 lines. And if we run the tests or run the code, let's see how fast that runs. Well, that one looks like it timed out. That one's hanging. There we go, 133 milliseconds. 204 milliseconds, 172. So yeah, let's call that 133 milliseconds to actually run the code. So that's what we want to improve. We want to cut the number of lines in half, cut the number of tests in half, improve our test performance, improve the run performance. How are we going to do that? The secret to this challenge is to understand that microservice architecture is both a design technique and a protocol choice. So what we want to do is we want to keep the design technique. We want to keep the way that the code is being isolated, but we want to replace the protocol, which is the network HTTP calls, with something that is faster and more reliable and lower complexity. Specifically, what we can do is we can replace that HTTP with a function call. And the approach I call it microliths, just because, microservice plus monolith. Also, a microlith is a real thing. It's the little shards of rock that prehistoric societies created. So it just seems like a great name. So a microlith is a microservice that runs inside of a monolith. So you're going to design your code just like you would design a microservice. So you design all your microservice APIs, but then you implement it inside of your monolith code. So instead of making an HTTP server, you just use top-level functions to represent your API endpoints. And then on the client, you're still going to use an infrastructure wrapper to isolate that call to the service, but you're just going to make a function call instead of making a network call. And if you do this, if you keep everything isolated behind that infrastructure wrapper and you use the top-level functions, you can refactor to and from a microservice when you need. You can go back and forth between a microlith and a microservice. So you're going to have a bundle of microliths, just like you have a bundle of microservices, and you'll choose some of them to become microservices as needed. The end result of this is that you're going to have much less complexity. Instead of having the complexity of the HTTP calls, now all we have is the complexity of that client wrapper and that top-level function that's providing our endpoints. And because we're retaining our bounded context, we can have clear team boundaries. We can have our encoding team over here working on the provider and our command line team over here working on the client. And because we've got that Route 13 client and Route 13 provider providing an abstraction, we do have the ability to refactor back and forth between our microliths and our microservice. So if we need to convert something to a microservice, we can do that and get that ability to upgrade our technology in isolation if we need. There's a comment came in from Pellet, and I do want to let you know your comments and questions are welcome. Go ahead and put them in the chat as we go. I'll have time at the end for additional questions as well. So Pellet says, I'm a big fan of doing this when building a project. You can extract a portion to a microservice when it makes sense and only pay the overhead when it's truly worth it. That's exactly right. Because you can choose to do this at any time, and there is a cost for doing this the microservice complexity, you don't have to incur that cost until you actually need it, which can be a ways down the road. Seems like the hardest part is maintaining the discipline in the team to keep the boundaries clear. Yeah, that is a challenge, but what you can do is you can actually use static code analysis to say that the only code that so you just like we have in our code here, you see we've got sort of a monorepo. You can define a static code analyzer, a linter, to say that no code outside of Route 13 service can call anything except for that top level module. So you can enforce the separation with tooling. Pellet went on to say, I forgot who uses the phrase, but talked about delaying decisions like this until the latest responsible moment. Yeah, that's a famous phrase from the Lean community. I first heard about it from Mary and Tom Poppendick in their book, Lean Software Development. I don't know if they're the originator of it, but I think that's where I heard it from. So yeah, I really like this microlith idea, and there may be another term for it. I just came up with microlith because it's clever and cute. But I really like this microlith idea because it allows you to delay the complexity of the microservice while still leaving the door open to refactor to the microservice as needed. And it is not either or. You can have a collection of microliths and convert one or several to a microservice as needed. So let's do it. Let's actually do this. We're going to do it in reverse because we've got this microservice architecture already. So we're going to start with a microservice and we're factored down to the microlith. And we're going to see how that affects our complexity and our performance. So we'll start with a microservice and end with a microlith. So let's go ahead and get to that. The way our code is set up is everything is in the source directory here. And we've got some shared code that we wrote in Node modules, not to be confused with the third-party code here. We've got our command line application, and we have our actual microservice code. So what we're going to do here is we're going to refactor our microservice back down to a microlith, and the way we're going to do that is by starting with a microservice. Now the microservice has all this stuff in it to do HTTP serving that's honestly not relevant to us, and it has the actual Route 13 logic. This is the only essential complexity in this part of the application. The top level entry point is right here in our Route 13 server. What we're going to do is we're going to change this so that instead of having this present HTTP endpoints, we'll just have a simple function call. Now, in order to make this easy to refactor, I'm going to keep the microservice and microlith both available side by side until we don't need the microservice anymore, and then we'll take it out. So I'm going to start out by adding a test saying that it exposes function to transform text via Route 13. See, exposes or publishes function. Now, I don't actually care how the Route 13 works. So I'm going to say that our expected value is just going to be the result of calling our Route 13 code with some text. And what that expected value is not important to me. Now, I call this approach collaborator-based isolation. It's a sociable test, and then it's actually calling the real logic, but the test is isolated from changes to that logic because we're asking the code what the answer should be. Now, collaborator-based isolation isn't appropriate in every situation, but in this situation where we're just exposing the function, we don't care what the function does, it seems appropriate. So I'll require that library. And then the actual result is going to be the result of calling our server with the transform function. And I'm going to make that an async function. And the reason is that in JavaScript, making something asynchronous, having it return a promise, pollutes the entire call chain. And I want to make this easy to refactor back and forth between the microlith and the microservice. So I'm going to make this asynchronous from the beginning so that when it changes, I don't have to change all the callers. So we'll await that result. We'll have to make this asynchronous. Let's get rid of those. And then we'll assert that the actual is equal to the expected. Now we can run the tests. We can have the test run automatically by using the watch script /watch.sh on Mac and Linux, watch on Windows. And I'm going to use the quick option to tell it to only test and lint the things that have changed. Okay, and it'll also make a nice little sound when things pass or fail. So let's see, I got an extra quote there. Let's try that. Okay, now it's failing because transform async doesn't exist. I'll go ahead and add that. Do a little bit of runtime type checking here. And then we can just call the route13 transform. And we'll return that result, but we're going to await it so that it returns a promise rather than just the string. And I'll need to import that or require it like that. Okay, that's it. That's all we have to do on the server side. We've now exposed the underlying logic through a top-level function. It's basically doing the exact same thing that the endpoint does when we route to it, except obviously much simpler. So now that we've done the server, now we need to do the client. Now in our client code, we abstract all calls to the server behind this code right here, route13 client. That's the one that's responsible for actually making the microservice call. And then that's used here in the route13 command line interface. Now the code right now depends on HTTP client to make that call, but we're going to re-implement this so that it just talks directly to the provider, to the route13 server. So I'm going to start out in our tests here, and I'm just going to change the tests one at a time to call to use the new function. Now I could modify this code directly, but that's a big change to make and it's going to cause our test to break, and I want to be able to run our test piece by piece. So I'm going to refactor this incrementally. So what I'm going to do is I'm going to start out by just renaming this to old transform. That of course is going to cause all of our tests to break. So let's go into our client code and find all calls to transform, which I've already pre-built here. I'm going to rename route13 client.transform to route13 client.old transform. Our tests are still failing because they're sociable tests. So our command line code that's calling into transform is failing because that function doesn't exist anymore. So I need to open up our route13 command line code. Oops, that's not what I meant to do. And right down here, I'll change this from transform to old transform. And there we go. I really like sociable tests because it informs you when you do something like this that breaks the callers that depend on the thing you're changing. Pellet has a comment. Perhaps I'm not understanding await keyword. Do you need to await when you were returning a promise? I thought that was the sugar that told JavaScript to block until the promise was resolved. Yeah, so Pellet here is talking about what we did in our server. Let me go ahead and bring that back up. Right here, when I said async, transform async, and then return await row13.transform. I could have done it like this, and then it would return text. But because I've marked this as async, that is going to cause this to return a promise. However, my linter complains if I use an async method without an await keyword in it. So that's why I used await here, even though it's not strictly necessary. So I hope that answers your question, Pellet. Okay, back over here in our client, we've now renamed transform to old transform, and we're ready to put in the new method call that will call directly to our server. Now I'm going to do that test driven, and because we're going to be deleting this old HTTP client code, I'm going to just modify the existing tests in place. Now the way our existing code works, it says it makes the request by creating the client, calling the transform via this thing which calls old transform, and then checking to see that we actually made the HTTP request we want. That's obviously not what we want to do here. And I'm actually going to change the test name too. I'm going to say it transforms row13 text by delegating to provider. We'll get a row13 client. I'm not going to modify this existing create client because there's other tests that use it, and also we don't need it because our code's going to be simpler. So I'm just going to make the row13 client directly by saying create. Then our actual value is going to be row13 client dot transform async with some text. And then our expected value, I'm going to do it with that collaborator-based isolation again. I'm actually just going to call the provider and say that the expected result should be whatever the result of calling that is. And again, it's because I don't care what comes out of that. I just want to make sure that our row13 client is making that call. And then all of this is no longer relevant for this new code. So we've got a row13 client. We're also going to need the server, which is up here in the service. Maybe I did that wrong. It can't find the row13 service. Oh, it's row13 service / row13 server. There we go. Now it's complaining that transform async is in a function, which is good because we don't actually have a transform async yet. So that will take some text. I will do some static type checking on that text. And then I'm going to return the result of calling the row13 server transform async with the text. Now I could do it like this and just return the promise, but I find the code easier to read when I have explicit async and await, so I'm going to do this, even though it's technically not required. Now that's not going to work because we need to require the row13 server, so let me bring that in. But now I'm thinking that will work, and it does. So now we've implemented the direct call, and technically that's all we need. But let's go through and make sure that we've got everything else taken care of. We don't need to worry about parsing the response because parsing the response is something that we do with the HTTP client where it's returning text. But here we're making a direct function call, so that's just not an issue. Our code is written so that it will track requests so that the command line test can check that the row13 service was called correctly. I want to keep that. So let's go ahead and modify that. We'll say that we've got a row13 client, which we get by creating the client. We're going to track requests on it. We're going to call the transform, but we'll do that directly. And then we'll expect the result to be no port, just the text. And I expect that to fail because we didn't set up our transform async to do any request tracking. Now, if you're curious about how the request tracking works, you can find it by going to jamesshore.com/s/LNL. That will give you the Tuesday Lunch and Learn archive. And I changed this recently to have a different layout. Down here in nullable output, it explains how the request tracking works. But basically, what we're going to do is we're going to emit an event, and then we've got some request tracking code that's going to handle that. So right here in transform async, we just need to say this.emitter.emit our request event, and then our data, which I believe is going to be text, like that. There we go. Okay, so we transform the text, we track requests, then we've got our failure paths. Fails gracefully when status code has unexpected value. Well, that can't happen. Fails gracefully, body doesn't exist. That can't happen either. Body won't be unparsable. It won't have an unexpected value. It won't have more fields than we expect. All this complexity that can happen with network calls just doesn't happen when you make a direct function call. Cancellation. We only have cancellation because the network request can take too long. So we can take all of that out too. We'll get rid of that. We'll get rid of that. All this stuff. I love deleting code. I love removing complexity. Okay, now we have nullability. It is possible for our row 13 client to be created in a null state where it doesn't actually make the network call. That's a little redundant here because we are not making a network call, but I'm going to leave it in for now because our tests do depend on it. So we're going to say that it provides a default response. We're going to create the null version of the row 13 client, and then we will say that the response is based on row 13 client.transform async. And we're going to expect that that response is our null response. So let's run that. Of course, right now it's actually making the real call. So we need to implement the nullable approach for this. Now again, if you're curious about how this works, you're going to look in the back episodes. That's jamesshore.com/s/LNL, and you're going to look in the testing without mocks episode. That will tell you all about how we're doing these nullables. But for now, can tell you that we just need to be able to inject the row 13 server so we can control it, and then we're going to make an embedded stub that we can use in our nullable version. So for the real one, we'll inject the real server, and for the null one, we'll inject a null row 13 server. And then in our transform, and then we'll have to get it here. We'll save it into an instance variable. And then down here, we'll use that. Now it's complaining that null row 13 server is not defined, so we'll come down to the bottom and we'll make a function that will return an object that will represent our null row 13 server. Of course, our real row 13 server has a transform async function, so we'll need to emulate that. This is an embedded stub, and again, check out the archive for details on how it works. We'll just make a transform async and return some value. I believe we want null row 13 client response. There we go. Now, I'll be honest, we don't actually need to have the ability for a row 13 client to be nullable. We could do sociable testing instead. But for now, I'm trying to keep the number of changes to the minimum so that we can refactor this and be done safely without having to change a lot of our existing code. Once we have that working, we'll come back and look at how we can simplify it further. So we provide the default response. I want to say that that can be configured. So again, we'll just call row13.client.transform async. We're saying it can be configured with a specific response, but let's see, we need to await this. But I think it's just going to give us the default, which is null row 13 client response. So to deal with this, we're going to need to take our options from here, pass them into our null row 13 server, and then in our null row 13 server, we'll take our options, do some type checking on those options. I'll do it the same way we did before. And then let's destructure this down to a response that defaults to a null route13 client response. And then we can return that response. There we go. Okay, we can configure it. We can force an error. The reason we do this is because the server can fail because there can be network problems, and we need our client code to deal with those errors. Now, in our case, the chances of errors are basically zero. If we get an error, it's because somebody made a programming mistake somewhere. And I generally don't write my code to fix programming mistakes. I actually just go fix the programming mistake rather than writing code to work around programming mistakes. But for now, in order to keep things as similar as possible, I'm going to go ahead and implement this. So we'll say that we're going to assert that we get this my error when we call transform async. That's not going to happen because we haven't programmed that yet. But what we can do is we can say that we also get an error out of this. And then if we have an error that's not undefined, we can throw the error. Okay, and then finally we have the ability to simulate hangs. You know, honestly, that is never ever going to happen. I'm going to take that out entirely. And that is our route13 client. We've converted it from a microservice to a microlith. We've left the microservice client code intact for now, but as soon as we get rid of that, we can delete it. As soon as nobody's using it, we can delete it. I am going to come through into here, though, and say that in our null route13 server, we do not allow a hang option. And because we have sociable tests, that's going to cause our route13 client tests to fail. So let's now go into our route13 command line. Let's go into our route13 command line tests and see what's going on. So our route13 command line is complaining that we had an unexpected parameter hang in line 87. That would be in our test. Okay, so here's the issue. We have the ability to make this hang, but we've taken that out. So I'm going to take that out, and that will probably cause something to fail. But actually, no, it didn't. I would have expected this test right here, the test that says we time out, to fail. That is no longer relevant in the new code, so I'm actually going to just take that test out entirely. Code's no longer going to time out. And we'll go into our route13 command line route13 command line interface code, and the real work of it is happening right here. And here's where the timeout's happening. And I'm going to go ahead and take that out because we're not going to need it with the microlith approach. So rather than needing to do all the timeout stuff, we can just await the transform promise that we get from our old transform. And now we no longer need the ability to cancel the requests, and we no longer need the timeout. And we no longer need a clock, which means that we should probably not pass the clock in here, or return it here, or make it here. Which means that on line 30, we shouldn't worry about the clock either. And we don't need to worry about it here. Okay. So there we go. We've got our command line using, or actually, no, we're not quite done yet. Now we actually need to make it use the new transform code. And that should just be a simple matter of calling transform async. And that's going to return the transform promise. We are getting a failure from one of our tests. We're saying that the code that calls the route 13 service is expecting the port to be part of the call, but of course we're not doing that anymore, so we can just take that out. And there we go. That should be it. Should now work without talking to the server. So I'll turn off the server, and there we go. We've successfully factored from a microservice to a microlith. We're not done, but this is the basics. Now that we've done this, we have all this dead code, all this stuff that we just no longer need. So now we can simplify everything. We can get rid of all that accidental complexity. And I love this part. So let's take a look at this. Well, first we don't need this or this. We have it saying that it's going to output an error when the route 13 service fails, but it's not possible for that call to fail anymore. So let's take that test out. And let's take out the try catch here because, again, this code can't fail unless somebody's made a programming error. And if they make a programming error, I want my code to crash so that I'm informed about it. I'm going to fix the programming error. We no longer need to pass the port in. So let's change this code. Let's see. Let's change the test to say that our arguments don't include the port anymore. We're just going to say, give me the text. That's going to fail because now we're expecting one argument, and we'll make that the first one there. There we go. Now we don't need this. And now that we're not simulating any errors, we don't need to actually use the nullable version of our route 13 client. We can just do a sociable test. We can call the server for real because it's running in the same process and it's easy for us to do that. And by doing that, we'll now be protected against behavioral changes that the service, the people who are writing the service make. And that's valuable. So let's go ahead and do that. Lars says line 28 in the string also mentions port. Thank you. So you'll change that. And we'll change that here. Okay. So we don't need to create null. We can just do it for real. Which means, oops, that's the command line. Right here, we'll create the real route 13 client so we won't pre-configure any of the responses, which means we don't need to do any of this stuff. Now this is going to fail because now we're getting the real result of calling our code back. So let's go ahead and change this from my text to hello, and this from being transform text to be URYYB. Okay, and then I think I can make this more readable by inlining this and inlining this. We don't need that response. We don't need this to be multi-line anymore. We don't care about the request that we make, because if we don't make the right request, the sociable test will fail, which means we don't need any of that. Here we don't need to track requests, which means we don't need to return them. Here we don't need to return the run promise because that's something we were doing to deal with a timeout. So we can just say await CLI.runAsync and make this an asynchronous function, which gets rid of that, which gets rid of that. There we go. Look at all that complexity we got rid of. I love it. Over here on the command line production code, we can get rid of this and this. Okay, so that's our command line simplified. Now let's move on to the client code, or the route 13 client. Now we've already changed all of our tests over, but so let's go ahead. Well, I've got something else I can do with the test, but first, I think we can now take care of all of the HTTP client stuff because we're not using it anymore. So I can get rid of old transform. I can get rid of track request because we're not doing that anymore. Except it's being used in the test, so let's go ahead and get rid of it in the tests. We don't need to validate and parse the HTTP response because we're not doing that anymore. Oops. That means this is dead code. Okay. Now over in the tests, we've got all this nullability stuff, but we're not using the nullable anymore, so we can get rid of that. This is dead code. This is dead code, and this is dead code. As is this, and all of this, and this, and that. I love deleting code. Okay, since we're not doing the nullable stuff anymore, we can get rid of the create null, which means we don't need the null route 13 server, the null client, the null response. Which means that we don't need to inject the route 13 server. We can just use the real thing. So we can take that out, and take that out, and take that out. And we're not tracking requests, so we don't need to emit any events. Okay, that's good. But that's not all. A route 13 client depended on HTTP client. We're not using that anymore, so we can delete it entirely. That's that. Okay, let's check that in. We have simplified the route 13 CLI code. Over on the server side, there's a lot of complexity we don't need there too. Serve was the command line code to start the server. We're not doing that anymore. We can take that out. In the server tests, we've got all this code to start the server, log requests, do command line processing. None of that matters anymore. Which means we can get rid of that and that. And then in the actual server code, the only thing we really need is the transform async. We don't need to start the server or anything else. In fact, having a class here is a little bit redundant. We can just say exports.transform async equals async function. All right, all the routing code, no longer relevant. Let's get rid of it. Logic code, we still need that, that's essential. And then here in the infrastructure, we've got HTTP request and server. We don't need any of that either. I love it. And then in the shared code, we've got some shared infrastructure. We've got this clock. The clock was to deal with timeouts. We don't need that anymore. Let's see, but I think the log uses it. So let's delete the log first. Not logging anymore because we're not running a server. And we can get rid of the clock as well. And there we go. That is everything. We've successfully converted from the microservice to the monolith, and we've gotten rid of all the accidental complexity. Now, there are a couple other things we could do that I'm not going to do today because of time. We could change this from route 13 service to route 13 provider, which is a more generic term for something that could be either a microservice or a microlith. Similarly, this could be a route 13 provider instead of a route 13 server. We could also move the command line infrastructure out of the shared code and just down into the specific route 13 command line code. Again, I'm not going to do that for time reasons, but it's something you could choose to do. Let's go ahead and check this in. Okay, I think that's everything. So let's see where we ended up. Our goal was to cut the number of lines of code in half, to cut the number of tests in half, to improve test performance, and to improve run performance. Let's see how we did. Let's see, what happened to that scratch pad I made? There it is. Okay, so our line count was 3,980, and now it's 1422. So we've cut that by more than half. It's about 35% of the previous size. Lars says, additionally to what you showed, one could probably delete one Docker file and at least one Kubernetes config file, as well as repurposing the person whose full-time job is maintaining and configuring Kubernetes to do something actually useful. Sorry. I'm not saying it's not useful, but there's a lot of accidental complexity there. So that's our line count. How about our number of tests? Where are we at on that? Let's run it. Let's do a clean run of the test so it runs all the tests. So we've gone from 172 to 68 tests. So we've cut the number of tests to 40%. And let's see what the test performance looks like. So it looks like 1.37 is our best answer. Yep. So we've definitely improved our test performance. Now it actually was more dramatic for me when I did the rehearsal. When I'm running the streaming software, it really cranks on my computer and actually gets worse over time. But the performance was actually doubled when I wasn't running the streaming software. And then finally, let's look at the runtime performance. Looks like 29 milliseconds. So we have cut that down by quite a bit as well. So our test performance went from 167 to 137, which is a slight improvement. And our runtime performance went from 133 milliseconds to 29 milliseconds, which is a substantial improvement. And actually would be larger in a real world situation because we were running both processes on the same machine. Whereas in a real world situation, you probably have them on separate servers. So now you've got all that cross server latency. So that is microservice infrastructure or microservice architecture without microservice overhead. What we've done here is we used a microlith approach. We designed our code as if we were going to use a microservice, but then we made function calls instead of an actual network call, which cut out all the complexity that we would have had with the microservice approach. But we left the door open for us to refactor back to the microservice approach in the future if we needed the ability to upgrade libraries in isolation or some of the other benefits of microservices. I have time for additional questions in just a moment. Love to hear your thoughts. Before we wrap up, a couple of reminders. This is the last episode of Tuesday Lunch and Learn. I'm going to be working on the book. And again, that's being done entirely in the open. So you can read the chapters as I finish them for free on my website. Go to jamesshore.com/s/AOAD2 to see that. The first chapter is already up. And then there's a link to the open review mailing list if you'd like to provide your feedback, which I'd certainly appreciate. Or you can go to jamesshore.com/s/updates to be informed when new chapters come out. Or you can follow the hashtag AOAD2 on Twitter. And then finally, I'd also like to remind you that if you liked what you saw today, I do provide private training and consulting for folks. Typically, when people hire me, it's always going to be in your programming language using your libraries and frameworks. Often, we're going to be doing work in your actual code base so you can see how to apply the ideas for real, because it's always a challenge to convert the ideas from a classroom exercise like this to real world work. If that's something that you think you'd be interested in, I work in Node.js, I work in front-end JavaScript, I work with TypeScript, Java, C#, and .NET. Go ahead and send me an email, jshore@jamesshore.com, if you'd like to take advantage of that, or visit me online, jamesshore.com. Got some good comments coming in. Pellet says, are you planning on doing another Lunch and Learn series at some point? Thanks for asking, Pellet. I don't have any current plans to do another series, but I probably will be doing more live streams at some point. So go ahead and follow me on Twitch if you're interested in that, or again, follow my Twitter. If I do additional live streams, though, it'll probably be Agile related topics around the stuff that's going into the book. So I expect to be writing the book for the next half year to a year. It's going to take a lot of time. So, hey, hire me. I could use the money. Because it's a lot of work to put together a book, and it does not pay all that well. I'll tell you that. So if I do additional live streams, it will be about the stuff that I'm putting into the book, and it won't be as frequent or as regular as this. Pellet also says, wanted to say thanks for the current series, learned a lot for it. Hey, thanks for watching. To all of those of you who are regulars, Pellet, Uncle Scientist, Charlie Pancakes, really appreciate you, your support and following along and giving me somebody to chat with. Lars says, thanks as well. Thanks for the book. Yeah, so I'm really looking forward to it. I'm not going away, but I am stopping the live stream. Again, go to jamesshore.com/s/AOAD2. Love for you to participate in the open review mailing list and share your feedback about the book. And Uncle Scientist says, someday we'll finish up that cribbage scoring tool to handle the different phases. Yeah, actually, if you look on my GitHub, Uncle Scientist, I do have a finished version of the cribbage scoring tool in one of the repos up there. I think it's I don't remember what it's called, but it's one of the TDD courses I've got online. All right. Lars says, you should take today's video, play it in reverse, and then ask, if you think you should do microservices, are you sure you want all the extra complexity, and can you do it well? Some people might rethink their enthusiasm about microservices and Kubernetes and such. In a sense, the whole Lunch and Learn series has been an exercise in doing work that we didn't need, because we started out, this first episode, we built the route 13 logic. And then in this second episode, we built the command line, and then we were done. We were basically at where we're at now. And then all these other episodes was just adding all the microservice complexity. And then here, finally at the end, we've come full circle and we've taken all that back out, which is, of course, where I'd prefer to start. Pellet says, do you have any blogs or something about testing without mocks that includes databases? That is something I'm not sure how to do well at the moment. I don't have any blogs or material about that online, although that would be a great topic. For those of you who are having trouble figuring it out yourself, it's a good thing to bring me in to help you with. Sorry, I guess I have to keep a few things to myself, otherwise nobody will hire me. Pellet says, if you want to scare people about microservices, bring up the term YAML engineering. Lars says, would have been a short series if I'd stopped without microservices. Yeah, and a big part of this series was all about how to do test-driven development with infrastructure and how to keep that fast. And I think microservices were a great example of how to do that. Just because they weren't strictly necessary and often aren't as necessary as your architecture astronauts might want them to be, doesn't mean that knowing how to do them when it's appropriate isn't a good idea. It is a good idea to know how to do them. Just don't apply them. As with anything, focus on where the essential complexity of your system is. Don't create accidental complexity. Don't use the stuff that's cool that everybody else is doing just because they're doing it, because There's a lot of programmers out there who are in love with complexity, in love with doing stuff that doesn't matter because it makes them feel smart or because that's what everybody else is doing. You can save a lot of time by avoiding those traps. And on that note, I think that is it. Thank you all for coming along on this ride. It's been 4 months of episodes. I've really enjoyed doing it. Again, appreciate everybody who's followed along, all the comments we've gotten. Again, continue to follow me on Twitch or on my Twitter at James Shore, because I do expect to do additional live streams in the future, just not on a regular basis like this one. So thanks again, everybody. And I will see you all, well, whenever I see you. And I hope to see you on the Open Review mailing list. Again, jamesshore.com/s/AOAD2 to get that information. Thanks again. See y'all later.